In this demonstration, we'll launch different kinds of application and API attacks and show how different protection platforms respond to the attacks. We'll use Postman to launch the attacks via API requests. The first attack is a traditional classic SQL injection. And we'll look how a traditional WAF, in this case Cloudflare, responds to the attack. First, let's look at the Cloudflare config. Basically, I have all the defaults. I click on Firewall, Managed Rules. I have the WAF turned on. I have the modset core rule sets turned on, sensitivity to high, action is block. There's not much more I could enable on this. This is default out of the box. I didn't even set up any firewall rules for permit, deny. So let's launch our first attack. It's going to be, as I said, a classic SQL injection. We have one that puts an OR 1 = 1 here. We click send, and we get something back. And we learn that we've been blocked. The Cloudflare has blocked us. Okay, let's go see what happened in Cloudflare. If I click on overview, there's a log at the bottom. Looks like I have 24 attacks so far. Clicking the most recent one, I see a SQL injection that's been blocked, and here's my OR 1 = 1. Now let's launch a second set of attacks. In the second sequence, we'll launch about 30 different attacks, most of which are the kinds of API-based attacks we're hearing about so much these days. API attacks are different. There's no preset vulnerability or known bad for anything to leverage. Instead, attackers need to probe your APIs to learn the unique business logic of each API. The OWASP API top 10 list documents various types of attacks that are used by attackers as they manipulate the business logic. I have folders for each of those different attempts, those different types, and I will click run to create a collection. So here I've got about 30 of them that will execute all one right after the other. I'll click run and we'll get going. Okay, let's first look at the WAF. I have 24 events. If I hit refresh, let's see how many I have. Now I have 30 events in the WAF. It looks like the WAF has found 6 additional events. This time we will edit the columns and we'll look at path, the query string, and see what we have. So we see that the WAF has identified the OR 1 = 1 style attacks. There are probably some cross-site scripting in here as well that have been blocked. Yes, all of these are blocks. They're all either cross-site scripting or SQL injection. So we notice that we've got like 6 or 7 of these, and they're all like the first attack. They fit a known pattern. This type of attack was previously number 1 on the old OWASP list, but has been dropped to number 8 on the new API top 10 list. However, the WAF missed the other 23 attacks or so. These are the kinds of API attacks that we see today, where the attacker has to manipulate a bunch of API calls to see what's possible. So looking here at the SALT platform, I currently have 9 attackers with multiple attempts. That's one thing you get with big data, is the ability to correlate things together. I see that 16 days ago, there were 122 attempts by someone that had this authentication token. 25 days ago, 385 attempts by this particular IP address. So when I refresh this page, I see 2 more attackers. Both of them are from my Postman run. Some of those attacks, a token was used, and other attacks, it was not used. So I see the 2 of those there. If I click on one, I see various things, but the most important thing to note here is that I've got all the different types of attacks that were launched against this application. I've got a potential BOLA, I've got broken authentication, I've got several from the OWASP API top 10 category that were launched here that SALT was able to identify. So let's wrap up. We've seen that a WAF is able to identify an attack if the transaction contains a known bad pattern like SQL injection, cross-site scripting, but it could not identify any of the other API attacks. For these attacks, you need something that has context to understand how your API is unique and how it's normally used. Salt Security is able to identify not only injections, but more importantly, logic-based attacks. Salt leverages AI, ML, and big data to understand the unique behavior of every user across every element of every API.